Okay, in this video we're going to look at the log laws. So rules that you can use with logs. Alright, the first two are ones that we've already looked at. So the first one is a log base a of a to the x equals x. And the second one is a to the log base a of x equals x. Now these are just based on the fact that they are defined as inverse functions. So the log actually undoes the exponential. And the exponential undoes the log. Okay, so based on the fact that they are inverse functions, these are by definition true. Okay, so we don't need to have a proof of those. The next log law is this one. Okay, so it would be nice if we could have a distributive property here where the log base a of x times y would be the log base a of x times the log base a of y, but it's not. Just like in our compound angle formulas, it's not true for sine of a plus b. So we have some circumstances though where we do have some nice formulas, and this is a nice one here. Okay, so log base a of x times y is log base a of x plus log base a of y. Okay, and then the division, kind of similar. Log base a of x over y equals log base a of x minus log base a of y. Okay, and then we have power rule here. So log base a of x to the exponent r. What's neat here is that exponent can come right down in front, and then you have just log base a of x. Okay, so r times log base a of x, you bring that right down in front. And the last one, which is a special case here, so that we can use our calculators to calculate logs that aren't log base 10 or natural logs. So log base a of x equals log base b of x over log base b of a. So you can change the base to some other base as long as you do this. This is called the change of base law. Okay. Now this is nice if you want to change the base to base 10. So if you want to find log base 3 of x, then that's log x over log 3. So if you want to use log base 10. Okay, so here are the laws. Now we're going to give some examples of them. So for the first one, okay, so log base a of a to the x equals x. So here's one here. So log base 7 of 49. Okay, we want to turn it into something that looks like this. Well, we don't have the same thing here yet, so 7 and 49, but we can write 49 as 7 to some exponent. So it's 7 to the 2. Now it looks like this, so log base 7 of 7 to the 2 is 2. Okay. Now we're going to look at one for the next law. So log base, 5 to the log base 5 of 9. These two undo themselves, and you end up with just 9. So that's the second one here. Now, what about this one? So log base 7 of 15. Okay, so that's this law here. So the log base a of x times y. So we're going to break that up into something times something. So 15 can be broken up to 3 times 5. And then you can just write it as log base 7 of 3 plus log base 7 of 5. Okay. Now, what about this one here? Log base 3 of 243. Well, you can divide 243 by 9 and you get 27. So log base 3 of 243 is log base 3 of 9 times 27. Break that into a sum of two things. Okay. So log base 3 of 9 plus log base 3 of 27. And we know these logs. Okay. 9 is just 3 squared. 27 is 3 cubed. So we can write it like this. Okay, so log base 3 of 3 squared. Well, that's using our first law. We can just write that as 2. Log base 3 of 3 cubed. Again, using our first law, that's just 3. Add them together, you get 5. Okay. You could also write log base 3 of 243 as, so 243 is actually 3 to the 5, so you can write it like that and do it without doing this. So this is just an example of it being used. Okay. Now, here's the subtraction one, and with the subtraction one, we get to division. Okay, so we've got log base a of x over y equals this, or we could have this equals this. You can go backwards. Okay, so log base 3 of 27 minus log base 3 of 9. Okay, you can write it like this. And we know that it equals 3 minus 2 because of what we just did up here. Okay, so log base 3 of 3 to the 3 is 3, and this is 2. You subtract them, you get 1. Now, to put it as a division, we can write log base 3 of 27 divided by 9, based on our law. Okay, so we changed it to this one here, so we're going from this way to here. So 27 divided by 9 is 3, and log base 3 of 3 is 1, and we end up back with the same answer we got on the other side. Okay. Hopefully that justifies it somewhat to you. The next example, okay, so for our power rule here, where you can bring the power down in front, we're going to do this one here. So log base 3 of 27 to the 2, well, you can bring that 2 down in front. Okay, so that law allows us to do that. It brings that exponent r down in front. Okay. And log base 3 of 27, well, we can write that as log base 3 of 3 to the 3, which we've seen already. And that becomes 3. So 2 times 3 is 6. All right, another way to look at it. So, or log base 3. 3 times log base 3 of 3 is just 1. Okay, so we've brought that exponent down. And we just end up with 2 times 3, which equals 6. So that's another way of following those steps. Okay, and of our last one, so the change of base law, here we're going to see an example on that one. So log base 3, oh sorry, this is another example for this one. Log base 3 of 27 to the 2, so it's another way of looking at it. Log base 3 of 3 to the 3, which is the 27 part, to the 2, make that a 6. Okay, 3 to the 2 is 3 to the 6, and then you just get 6, and that part's 1. Okay. Now, this one here. So log base 6 of 5, based on our change of base law, could be log base 3 of 5 over log base 3 of 6. Okay, so the bottom part is the log of the base. Okay, so log of this over log of the base of this one. So I could have had 4 in here. I could have had 27 in here as the base. Doesn't matter. It always works. Okay, one way to check it is do something like this. So you could change it to base 10. So log, if you see log of x, that's the same as log base 10 of x. And that's what the main button is on your calculator. Okay, so here if you want to find out log base 6 of 5, well, we don't have a calculator button for that, or most of us don't. So you can just do log 5 over log 6 on your calculator. And then when you do that, you're going to get approximately 0.898. Okay, so that's the log laws. Next video I'm going to prove the log laws and do a couple more examples.